Welcome to the recursion part 2. The general structure for designing a recursive function is to start by working on the base case or the simplest cases that we know the answer without looking for it. The second part is to combine this base case with the recursive structures and combining these smaller subproblems in order to solve the big problem. And the third step is to do the first step, and the fourth step is to trust on the second step to do the recursion. A lot of examples are recursively processing lists and strings, because a string is a character followed by a string, and a list is an element that's followed by a list. We can see the recursive structure of strings and a list in their definition. So let S be a sequence of a string or a list. The first step could be use the first element of the list or a string to do something with it, and delegate the rest could be using the remaining of the sequence or characters to make a recursive call. For instance, we wanted to implement a function named mylen, which is going to return the number of characters in an input s. So let's work on the base case, the first case. We know that if the string is empty, the length is going to be 0. This is the simplest case that we can solve and know the problem, solve the problem immediately. The second part is to call this function one more time for the remaining of the string and put the answer on len rest. We assume that we know how to solve it, and therefore we just need to add to the remaining rest and add 1 to it, and this is gonna be our results. So in order to solve any problem, ask yourself, do you know the base case and how you can combine it in order to get the bigger problem? Another question can be calculating the power of b to power of p, and so the base case is going to be when the p is 0. We know that the b to power of 0 is 1, and in order to calculate the power of the remaining, we can call the power of b and p minus 1, and with multiplication of b by the remaining, we can solve the original problem. You can see the calling of the sequence of calls for calculating power of 3 and 3. B and P in this case are both 3. The power of the remaining is gonna be calculated by calling power of 3 and 2. In this case, we are stopping the execution of the first block and creating another block with B3 and P2, and in order to calculate the power of the rest, we need to calculate the power of 3 and 1, and again we have another case until we reach out the 0 that we can have the answer immediately using the base case. And with solving the base case, then we can solve the power of 3 and 1, which is the result is going to be 3, and the result of power of 3 and 2 is going to be 9, and finally we can have the 27 as the final answer. So at the end of this video, I want you guys to work on a practical writing function. I want you guys to write a function named simple distance that takes two strings s1 and s2 with the same length and returns the number of positions that these two are different. So you can start by answering what is the base case and what is the recursive structure. You can find out tips about solving this one on the CS4All course website. and please submit your simple underscore distance.py file as your submission after watching this video. Thank you.